I am going to calculate the natural frequency of the spring mass system by energy method. So this is our spring mass system. So this is m is the mass of the system, k is the stiffness of the system, and the spring is massless. So this system is under no external force or zero kinetic friction. So first we will write the total energy of the system. So here no friction force, all the non-conservative force are zero. So we can at any time the energy of the system is zero. So first we going to write the total energy of the system. So this is at equilibrium position or mean position. So I am going to give little deflection. So this is x, very little or very small deflection. So I can write the total energy of the system. So first I am going to write the energy of this spring. So energy of this spring is half kx square, and energy of this kinetic energy of this mass is half mv square. So the energy of this system is this. So the total energy of this system at any time is constant because there is no external force and no friction force. All non-conservative forces are zero. So the energy at any time t dE upon dt is zero. So first I am going this energy going to differentiate with respect to time. So this energy is I am going to differentiate with respect to time. So the energy of this dE by dt become half k into 2 into x dx upon dt plus half m 2v into dv by dt equals to 0. So now this 2 and 2 is cancelled out, this 2 and 2 is cancelled out. So now I am going to write this equation is x into dx by dt, and this equation is m, and this is the velocity. So velocity I can write dx by dt, and dv by dt I can write dx square upon dt square equals to 0. So this dx and dx by dt is common out, and I am going to divide, so it becomes 0. Now this equation become m dx square upon dt square जोड़ kx बराबर 0. So this is a standard simple harmonic equation. So this equation I can write dx upon dt square जोड़ k by m into x. So dx square upon dt square जोड़ k by m, this k by m is replaced with omega n square into x. This is a standard SHM equation. So this omega upon n square is k by m, omega n is equals to k by m. So the natural frequency of a spring mass system is equals to under root k by m. Thank you. I am going to solve another problem by energy methods, and I am again going to calculate the frequency of the system. So this is our another system. This is a spring, massless spring of a stiffness S, and this is one disc at its equilibrium position, or we can say at its mean position. So I am going to give a little deflection. So the position of the system is now here, and suppose this deflection is little deflection or very small deflection. So now I am going to calculate the total energy of the system. So this system is again under all non-conservative forces are zero. A non-conservative force in which means the work done, the whole trip of the force is zero. It means the system force is conservative. If the work done in the whole trip is not equals to zero, it means non-conservative force. And non-conservative forces are like friction forces, viscous force. So here all non-conservative forces are zero. So again I here, so energy of the system is constant, so again we write the total energy of the system and going to differentiate with respect to time. And so the total energy of the system is constant, so anytime the energy of the system is constant, so first we write the total energy of the system. So first we write the energy of the spring, like we can say potential energy of the spring. So total, first we write energy of the spring. So energy of the S is the stiffness. Suppose this disc of mass m and radius r. So first we radius r. So first we going to write the energy of the spring. So energy of the spring is half s x square, and this disc have two energy, like rotational energy and translational energy. So first I am write translational energy. So translational energy of the system is half m and v. This is translational energy of the system. And now rotational energy of this disc. So rotational energy of this disc is half I omega square. So now I am going to write this equation again. Half s x square, half m v square, and half I omega square. And this is disc. So the I is the moment of inertia of the disc. So moment of, we can know, and we know that the moment of inertia of the disc is mr square by 2, and this is angular velocity of the system. So we know that the angular v is equals to r omega. So we can write omega is equals to v by r. So again I am writing in the place of I is mr square by 2, and in the place of omega I am going to write v by r. Now I am going to differentiate. So this energy with respect to time. So this energy half s2 into x into dx upon dt, and this half mv square I am going to write half m into 2v into dv by dt, and this again I am going to differentiate. So this is, first we write half mr square by 2 1 upon r square, and this 2v into dv by dt. So we can write again this equation is equals to, first this 2 and 2 is cancel out, so we can write s into x upon dx by dt, and this 2 is going to cancel out, and this v I am going to write is dx by dt, and this dv by dt is dx square upon dt square. So again I am going to cancel this r and r, and this 2 and 2. So now this equation become 2 and 2 is cancel out, and only 1 2 is left. So I can write m into dx by dt into this dv by dt. I can write dx square upon dt square. So this d by dt become this dx by dt common out. So we know that the total energy of the system is constant, so I can write d by dt is equals to 0. So this dx by dt is common out, so dx by dt going to this side, so it's become 0. Now this equation become s x into m into dx square upon dt square half m dx upon dt square. So now this two term is same, so I am gonna add this. So now this equation, this total whole equation become 3 by 2 into m into dx upon dt square plus s into x बराबर 0. So this is I am going to write dx square upon dt square s into 3y2 into m into x is equals to 0. So again this is a standard simple harmonic equation, so we can write this term is replaced by omega n or natural frequency of the system. So omega n is equals to omega n square is equals to s 3y2 into m. So natural frequency of the system is s upon 3y2 into m. Thank you.